Hello everybody, it's your boy and we're back at it again with another maths video. Today's going to be an extremely short video where I'm going to be explaining the concept of a tangent. Now I did touch a little bit of this when we were dealing with coordinate geometry, where I said that sometimes you have a situation whereby a line is touching a curve at one particular point and it's known as a tangent. But tangents come up a lot in calculus, in differentiation. So in this very short video, I'm just going to edify the idea of what a tangent actually is. So over here, I have three examples, 1, 2, and 3, illustrating what a tangent actually is. So in the first example, I have a curve that looks like this, and I have a straight line here that's only touching the curve at one point. And the point that that straight line is touching the curve is this one circled here. It's over here, and here it's over here. So as you might have guessed already, a tangent is simply a straight line that is drawn to touch a curve, but it touches a curve only at one particular point. So when you look at this straight line here, it's touching the curve at this point only. When you look at this tangent here, it's touching this curve here at this point only. And when you look at this tangent, it's touching this curve at one point only. So that's what a tangent is. A tangent is simply a straight line that meets a curve at one point only. That line, it's not going to intersect or meet the curve at any other point. It touches the curve at one point only. So what do tangents have to do with calculus? Well, when we're dealing with differentiation, remember, we're simply finding the gradient of a point on a curve. The thing that you have to realize is that the gradient of a tangent at a point is the gradient of a point on a curve. For example, let's say I want to find the gradient of this curve at this point here. The way I would normally do it is I would draw a tangent to the curve at that point, and the gradient of that tangent would give me the gradient of the point. So that's how tangents are actually linked with calculus. Whenever you are finding the gradient of a point on the curve by differentiation, what you're actually doing is you're actually finding the gradient of this tangent. If I was to give you this curve here, this upside down curve, and I asked you to find the gradient of this point here, what you're actually doing is you're actually finding the gradient of this tangent that I've drawn here. When you look at this curve here, if I ask you to find the gradient of this point on this curve, what you're actually doing is you're finding the gradient of this tangent here. What you've normally been doing is you draw the tangent first, and then you calculate the gradient of the tangent accurately by drawing the thing on graph paper and so on and so forth. But in calculus, we're doing it the other way around. We are using the technique of differentiation, which I've already showed you in my previous videos. We're using the technique of differentiation to calculate the gradient of that point on the curve without drawing anything. But that answer that we're getting, the gradient that we're actually calculating, it is the gradient of this tangent. So now we are no longer drawing the tangent to get the gradient, but we are rather calculating the gradient to figure out the gradient of the tangent. So anyways, that's it about tangents. That's what a tangent is. A tangent is simply a line that intersects or meets a curve at one point only. It's not going to cut the curve at any other point, like these two examples. And what do tangents have to do with differentiation? Well, when you actually find the gradient of a point on a curve, you're actually finding the gradient of the tangent, because as you all know, whenever you want to find the gradient of a curve without using differentiation, you sketch a tangent and then you find the gradient of the tangent. But now we are actually calculating the gradient using the techniques of differentiation. So that answer for the gradient that you're actually getting, it is the gradient of the tangent. Anyway, that brings us to the end of the video on tangents. If you enjoyed the video, please like the video, comment on the video, subscribe to the channel, click the notification bell, and share the channel. Until next time.